Yesterday we were talking about contacting type temperature measuring device, and I think we have completed temperature measuring IC along with basic temperature measuring devices, RTD, thermistor, thermocouple, right? So this part we have discussed in much detail. And today we were supposed to discuss about pyrometers. Okay, so I will start straight away with the pyrometer and we'll go in detail, right? So this is an overview, right? We also discussed about thermopiles yesterday. Fine. So before going in pyrometers, we already know that the method of measuring temperature without physical contact is called pyrometry, and the devices which are useful called pyrometers, right? So mainly we have two kinds of pyrometers. One is radiation pyrometer, second is optical pyrometer, right? And infrared pyrometer is also there, but mainly we are categorizing them in two parts: radiation and optical. Fine. Now, before going in the basic structure of radiation pyrometer, we should actually recall the Boltzmann-Stefan law, right? So Stefan-Boltzmann law states that the power radiated is proportional to the fourth power of the temperature, right? So if I measure this radiated power, I can measure the temperature. This is the main concept, right? And this is the working principle, right? Or we can say the physical law on which pyrometers are implemented, right? Or designed, right? So here the temperature we deal is in Kelvin and surface area, temperatures, power 4, then Stefan Boltzmann constant and emissivity of the material, right? That will be equals to the power radiated. Fine. Now, before discussing or before explaining this diagram, I would like to just give you a few minutes to see the structure. Okay. See, this is non-contacting type temperature measuring method, right? So you can see that there is hot object, right? Hot object jo hai, you can see the leftmost side, there is a hot object, and then you have a lens. After lens, you have a mirror, and then on the right hand side, you have an eyepiece, adjustable eyepiece, right? So you have an eyepiece on the right hand side. Okay. Now, what you are doing is you are having a hot object, and through lens, you are adjusting the mirror and you are generating that reflection on a temperature detector. So at the bottom side, you are having a temperature detector. So what temperature detector is? It is nothing but a series of say thermocouple. Matlab, it is a thermopile, right? And on thermopile, I am trying to reflect that radiation coming from the hot bottom, right? And then you have a temperature indicator. So this is one kind of a design in which I do not require the physical contact with the hot body and I can measure its temperature. So obviously I can understand that this can be useful for a temperature in we can say for higher range up to say 3000 degrees Celsius or even more than that, right? So this is kind of non-contact temp structure and this is called radiation pyrometer, right? Structure is clear to everyone. Please respond to chat box. Fine. Good. Now, if we just go ahead. So, radiation pyrometer is a non-contact temperature sensor that infers the temperature of an object by detecting its naturally emitted thermal radiation. So we are measuring the thermal radiation. An optical system collects the visible and infrared energy from an object and focuses on a detector, as shown in the figure. Right? Good question. What is the need of the lens? Can anyone tell me what is the need of the lens? What is the purpose of lens in this structure? Question is asking about what is the need of lens. Can anyone tell me? It is focusing, right? So basically what is happening, you are having an eyepiece through which you can adjust the position of the lens and accordingly you are trying to see the hot object, and then through lens you will have a reflection on the mirror, and then you will be having a reflection on the temperature detector device. It may be a thermopile. So this is lens is for adjustment of the object, right? Eyepiece से आप देखोगे कि object clearly दिख रहा है कि नहीं through lens, and then you will have a reflection coming on the hot, say measuring device, or say temperature detector, right? We can use any kind of a lens, right? Here they are on the concave type of a lens, right?
सर लेंस का नीट रिपीट करो ना एक बार सर.
लेंस इज ओनली टू फोकस, राइट? आपको यहाँ से आई पीस जो है वहां से आप देखोगे लेंस के थ्रू बी एबल टू सी दी ऑब्जेक्ट प्रॉपर्ली, कि प्रॉपर्ली आपने माउंट मतलब यू आर टारगेटिंग दी हॉट ऑब्जेक्ट प्रॉपर्ली और नॉट, एंड देन इफ इट इज इन प्रॉपर लाइन ऑफ alignment, then it will have proper reflection on the mirror, and from that the reflection will be coming on the temperature detector. So adjustment of the hot object properly line in line hai ki nahi, everything you can adjust. You have to see from the adjustable eyepiece.
थैंक यू सर.
Yeah. So this is one of the basic structure. यहाँ पे our objective is to uh, just detect that radiation coming from the hot body, and then we can convert it the corresponding temperature, right? So that is our main understanding here. Fine. So radiation pyrometer जो है, we can discuss about its advantage, its limitations, and its applications, right? In advantage, you can straight away say that they can able to measure the high temperature, right? If you wish to note down few points, you can note down, because these things are readily not available in the book. You'll be able to get it after reading the whole paragraph or something like that. So you can write few important points. Advantages: it can measure high temperatures, right? Second, fast response speed. Okay. Yes, and here you are having non-contacting type measurement, so no need to contact with the target, right? So you can also measure the remote location body's temperature. Okay, right, and it is having moderate cost. Okay. Limitations की अगर हम बात करें, we also need to discuss about limitation. So here, as you know that radiation जो है atmosphere में भी थोड़ा absorb हो जाएगा. So because of that, there may be possibility of an error. So error due to absorbing media, right? So radiation जो है, it may not be 100%. There may be some sort of absorption in the atmosphere, also some media. And because of that, you may have error in the measurement of the temperature, right? Uh, Another thing is that you are having non-linear scale here. Whatever, because you are having power is proportional to temperature's fourth power, right? That means you are having non-linear relationship, right? And compared to the traditional temperature measuring devices such as thermocouple or RTD, this is comparatively costly, right? And you require wide temperature range, or say wide temperature span in this particular kind of a pyrometer. Okay? These are few of the limitations. But when you have measurement of say more than 2000 degrees Celsius, and you require non-contact sensors, type sensor, this is one of the good option. Applications की अगर हम बात करें, right? Already I told you that you can monitor the temperature of moving objects, right? So contacting type may need to make proper contact of the sensor with the uh, body whose temperature you need to monitor. Here there is no problem, so you can have temperature measurement for moving objects as well, right? So moving objects का temperature measure कर सकते हैं. Right. Second thing, use can be used in corrosive environment, right? Where we cannot use such traditional sensors, right? So corrosive environments में इसको use कर सकते हैं. And we can also use for the targets or the body who are not easily, which are not easily accessible, right? So जहाँ पे sensor mounting is not possible and you need to measure the temperature, right? So then you can go for non-contact method. You can use radiation pyrometer. Is it okay? Right. So advantage, limitations, and applications are clear. Please respond to chat box. We can now move ahead. Okay, an optical pyrometer, right? अभी हम optical pyrometer की बात करें. So here also the main fundamental is radiation, but if we go in much detail, यहाँ पे we are also uh, understanding about radiant intensity of a body, right? So if I tell you about the working principle, before that मैं आपको थोड़ा उसका application समझाता हूँ और I will just explain the structure of it. Okay. Now here you can see on the right side, this is hot body whose temperature you need to measure, right? Again there is a objective lens, right? And you have a bulb. यहाँ पे जो है it is a reference temperature lamp. This is a reference temperature lamp. This is absorption screen and there is a red filter, right? Red filter is that. And there is a eyepiece. Okay. Optical pyrometer जो है, it is having this kind of a telescope plus control adjustment for bulb intensity. It's a telescope structure, right? So you are having some remote body through lens. You are trying to focus it, and then you are trying to you are having a electric circuit in which we are adjusting the current flowing through the bulb. Means हम क्या करेंगे, हम लैंप की इंटेंसिटी को एडजस्ट करेंगे विथ रेफरेंस टू टेम्परेचर. अभी इसमें आपको बेसिक आइडिया क्या है, यू आर हैविंग आई पीस हियर, आप यहाँ से देखोगे और बैकग्राउंड में आपको दिखेगा यहाँ पे हॉट बॉडी का से बिकॉज ऑफ इट देयर विल बी सम लाइट इंटेंसिटी बेस उसका वेवलेंथ आपको मतलब यू विल बी गेटिंग सी बैकग्राउंड में आपको कुछ दिस इज योर फिलामेंट जो आपने यहाँ पे रखा है. दिस इज योर बल्ब फिलामेंट. पहले आपको इसको अच्छे से समझना पड़ेगा. बैकग्राउंड में यू विल बी हैविंग दी हॉट बॉडी, right? Now what will happen, you will have three stages. अब जब यहाँ से when you will observe through eyepiece, right, and there is a battery and there is a rheostat, so we will have some kind of adjustment. We can vary the position on the rheostat and we can change the current flowing through the circuit, right? तो हम क्या करेंगे, हम बल्ब का इंटेंसिटी वेरी करेंगे. कैसे वेरी करना है वो आपको अच्छे से समझना है. इसमें you have to observe from eyepiece, राइट. भी आई पीस से ऑब्जर्व करने के बाद क्या करना है, हमें हमें बल्ब का इंटेंसिटी थ्रू रियोस्टेट पोजीशन वी हैव टू वेरी. हाउ वी शुड वेरी, राइट, दैट इज इंपॉर्टेंट. सो व्हेन यू हैव बैकग्राउंड ब्राइटर, राइट, आप यहाँ पे देख सकते हैं फिलामेंट इज डार्क, राइट, कूलर देन वी कैन से दैट कूलर देन द टेम्परेचर सोर्स. आपका जो हॉट बॉडी था उससे अगर आपको फिलामेंट डार्क दिखे, that means your filament temperature is we can say that cooler than the temperature source. मतलब आपको filament का temperature कम है, right? So filament is dark, that is cooler than the temperature source. That is first case. So it's still cooler. So what you will do, you will still increase the current, right? So rheostat को you will adjust. Second, filament is bright, that is hotter than the temperature source. आपको filament bright दिखे, that means it is having higher temperature than the hot body, or than the source whose temperature you need to monitor, right? तो पहले हमारा filament dark दिख रहा था, in second case our filament is bright. Now let's discuss about third case. Exactly when you have temperature matching, means your filament temperature is exactly same as the source temperature or say hot body's temperature, then your filament will completely disappear. You will not be able to see the filament, right? So at that point, I will stop and I will fix that rheostat position, right? So what will happen when you will adjust this rheostat? You will first of all have your filament darker compared to the background. Then you keep on increasing the current at some value, right? At some value or at some position on the rheostat, you will be able to see filament brighter. Then you will come back, you will decrease, and you will try to exactly see the position of the rheostat at which your filament will be disappearing. Right? At that point, your temperature of the filament is same as the temperature of the hot body. So this will be the position of the rheostat, I can monitor that current, right? And I can indirectly convert that to the value of the temperature of the hot body of the target medium, right? So this is the way we can use this optical pyrometer. Am I clear to everyone? Shall I repeat any point?
सर जब हमें वो फिलामेंट दिखता नहीं है तब क्या रियोस्टेट का
या जब हमें फिलामेंट दिखता नहीं है तब आपको रियोस्टेट का पोजीशन नोट डाउन करना है, and at that time whatever resistance you are connected in rheostat मतलब क्या है, it's a variable resistance, right? So because of that the current will vary from the filament. So at that point when your filament is completely disappearing and you cannot see it, you have to stop and you have to monitor the current value from the circuit. Am I clear?
यस सर थैंक यू
So mainly our idea is to first of all start, when you will start your filament will be dark. That means your filament is cooler than the temperature source, means the hot body. Second, when you keep on increasing, आपको फिर filament bright दिखने लगेगा. That is hotter than the temperature source. But you have to again readjust. You have to come at the position when you will not be able to see the filament, and thus that at that time you will have equal temperature of the filament and the source, right? So that is your point of observation, or we can measure the temperature in that. Am I clear with this, everyone? Optical pyrometer. I want everyone's input. If there is any doubt, we can discuss in much detail. Fine. Good. So now if we go back to working principles, spectral radiant intensity of the radiated energy from a heated body at a given wavelength is proportional to the temperature of the hot body. This is the main idea. अब यहाँ पे देख पाओगे, यहाँ पे रेड filter यूज किया. Can anyone tell me what is the use of red filter? We are using that wavelength of red spectrum. That's why they use red filter. It's a visible wavelength spectrum. Right, so यहाँ पे spectral radiant intensity of the radiated energy from a heated body, the given wavelength is proportional to the temperature of the body. Hence, temperature of hot body can be measured in terms of spectral radiant intensity at certain wavelength. Right, so indirectly it will be able to give you the temperature of hot body. Fine. So after discussing about the detailed construction as well as the working principle or say main operation, we should now at least understand the difference between radiation pyrometer and optical pyrometer, right? And we can also discuss about its types. Okay, अभी इसमें there are two types. Okay, one is manual type. आपने जो human eye वाला structure देखा, this one is manual type. Here I am doing some kind of adjustment, or say observer is doing some kind of adjustment, and there are possibility of some kind of a human error, right? But हम क्या कर सकते हैं, automatic type भी available है. इसमें radiation detector acts as a sensor. Instead of we adjust it manually, there are sensors which can see approximate the wavelength and then can be helpful to measure the temperature, right? So the thing is adjustable eyepiece वाला structure, it is a manual structure, right? And you also have some automatic type radiation detectors सेंसर के साथ अवेलेबल होंगे जो आपको ऑप्टिकल ऑटोमेटिक ऑप्टिकल सेंसर और ऑटोमेटिक ऑप्टिकल पायरोमीटर की तरह दे कैन बी यूजफुल. ओके, हियर see, as I told you, in the manual type of optical pyrometer there are possibilities of human error, right? और दूसरा भी एक possibility है कि use of human eye restrict accuracy because eye responds to both color and brightness rather than directly to energy. तो हमारा जो eye का जो capacity है wavelength bifurcate करने का, according to that also you will have some kind of measurement error compared to the sensor performance, right? Sensor वाला जो है automatic optical pyrometer, compared to that the human eyepiece वाला जो pyrometer है that is manual may have some kind of a limitation. So human eye limitation है wavelength bifurcate करने की, that will come in the picture. Okay, if we talk about the range, इसका range up to 3500 degree Celsius है, but it can measure from 760 to plus 3500. मतलब कुछ टेम्परेचर के बाद रेडिएशन स्टार्ट होंगे. So when we talk about radiation pyrometer, optical pyrometer, both of them start from 650 degrees Celsius, right? और उसके बाद they can go up to 3500. Ideally, there are no maximum range limitations, right? But we normally use it for 3500. For 3500 degrees Celsius, we use the optical pyrometer. Okay. If we talk about advantages, optical pyrometer के जो advantages है, they are highly accurate. First thing is they are highly accurate, lightweight and portable structure. You have seen that there is a telescope kind of a structure, and after that you have a control circuitry to adjust the position of the rheostat of the current through the coil. Right, so it's a very small and compact structure. It's a portable kind of a temperature measuring device, right? And it is highly accurate. ठीक. Applications की अगर हम बात करें, so optical pyrometers are frequently used for calibration of radiation pyrometers. So दोनों में से accurate optical pyrometer ज़्यादा है. Sometimes we use optical pyrometer as a calibrator for the radiation pyrometer. Everyone is understanding? All points are clear? Advantages, types, and application.
Sir, can you repeat the application once?
Yeah, application is that, as I told you, that optical pyrometers are comparatively more accurate, right? So what we do is we use it as a calibrator. मतलब आपको calibration करना है radiation pyrometer का, then we can use optical pyrometer as a calibrator. Optical pyrometers are frequently used for calibration of radiation pyrometers. Fine?
Yes, sir.
Good.
सर दोनों में एक बार वो कंपैरिजन बता दो ना,
Yeah.
ऑप्टिकल और
Comparison में difference इतना है, यहाँ पे हम wavelength का reference ले रहे हैं bifurcation, and here both are working on radiation principle only, right? Hot body का जो radiation होगा उसके principle पे काम कर रहा है, but here spectral radiant intensity, if you see the principle, spectral radiant intensity of the radiated energy from a heated body at a given wavelength is proportional to the temperature. So here we are having wavelength. Other application may see, if you want to measure the temperature of a hot body whose temperature is higher than 2000 degrees Celsius and where you require more accuracy, तो वहाँ पे optical pyrometer use कर सकते हैं. For example, I want to monitor the temperature of sun only for just for say practical purpose or some demonstration purpose. Then you will not be able to go for optical pyrometer is the best option compared to other. Right? So optical pyrometer आप use कर सकते हैं, which we can take the judgment of the remote location bodies temperature. Right? But if we compare radiation pyrometer and optical pyrometer, तो optical pyrometer का जो accuracy है, that is higher. So we can also calibrate radiation pyrometer with the help of optical pyrometer. Okay, बाकी सारे applications जो है pyrometers के common, right? So just note down few important points because these things are whatever things I have covered. PPT में main points मैंने cover किए हैं. With few other points you need to note down. Just note down advantages of pyrometers. I think I have covered that slide. Yeah. Note down this point. Advantages of pyrometers over other temperature sensors. This may will be getting the clear understanding. First point, I think everyone can write. Pyrometer do not require physical contact with target. Right. So first point is that it's a non-conducting type sensor. So pyrometer do not require pyrometer do not require pyrometer do not require pyrometer do not require physical contact with target. Physical contact with target. Second point लिखो. Can be used to measure can be used to measure temperature of can be used to measure temperature of stationary and moving objects. Stationary and moving objects. Right, so here it's a remote you can monitor. So you can also use it for the temperature measurement of moving objects along with stationary objects. Okay. Third point, it can measure the temperature of targets. It can measure the temperature of targets in contaminating environment in contaminating environment as well as which are difficult to access as well as which are difficult to access. So as you know, already we have we have discussed in detail that these are non-contacting type, right? So whether the environment is toxic, contaminating, that will not make any difference, right? So you can use them for contaminating environment as well as the objects or the bodies whose temperature you need to monitor and where the mounting of sensor is not possible. Okay. And fourth point, which is also one of the advantage, practically or say practically you can use them up to temperature of 3500 degrees Celsius. You can use them to temperature of 3500 degrees Celsius. But theoretically, but theoretically, but theoretically, there is no upper limit of measure. Theoretically, there is no upper limit of temperature measurement. Okay, so these are the already you know that when there is a contact type sensor, there are few of the problems. अपने शायद RTD का example में था तो lead wire effect आ रही थी, right? Apart from that, if you require proper contacting, proper mounting, right? Yesterday I told you about installation of thermocouple, at which height you need to insert, right? Where you need to put them as a measuring device. So such problems you encounter, right, when you mount a sensor. Here you are having the non-contact temperature measure, right? So you need to adjust the adjust the lens properly, and then you can see them from the eyepiece. If it is, for example, optical pyrometer, you can adjust and you can get the temperature without even getting in contact with the physical body. Right? So this is an overview. So this was the topic relating with the pyrometers, radiation pyrometer and optical pyrometer. Okay. Infrared pyrometer आपको already मैंने कल बताया था कि वो infrared दोनों भी use होते हैं temperature measure main के लिए, that is one of the pyrometer, that is infrared pyrometer. Okay. And these are useful for high temperature ranges. Okay. And now if you compare the whole temperature measurement topic starting from basic devices like thermometers and volumetric expansion strips and all those things, bimetallic strips, and electrical temperature measuring devices. We discussed about RTD, thermistor, thermocouple, and temperature measuring ICs like LM35, or we have discussed about 85, right? So these are the different electrical temperature measuring devices. And if we want other options, तो हमने कल एक डिस्कस किया था, कल कौन सा ऑप्शन में डिस्कस किया था, piezoelectric temperature measuring device, right? These all are basically contacting type. और उसके बाद जो हमने आज डिस्कस किया दैट इज रिलेटिंग विद द पायरोमीटर, एंड पायरोमीटर जो है दैट इज नॉन कॉन्टेक्टेड टेम्परेचर मेजरिंग डिवाइस in which we have discussed about radiation pyrometer, then we discussed about optical pyrometer and infrared pyrometer. Right, so this is an overview of temperature measurement. Right, और parallel मैंने आपको already reference books जो suggest किए हैं. Right, you can use AK Ghosh along with instrumentation, industrial instrumentation by SK Singh. That book is also good for temperature measurement. Right, so those two books you can refer, and now you should be at least able to understand the fundamental application of temperature measurement.